Hey fellow coders, this is GameDev with Tony. In this video we're going to learn how to detect when game objects are clicked using raycasts and colliders in Unity. If your game uses a mouse, you'll need to know when something gets clicked, whether it's to show information, open a menu, or drag an object to a new spot on the screen. I put together a sample project that covers different types of clicks. We'll start with the basics, detecting when the mouse clicks on an object, then we'll build on that with click and release, toggling, dragging, and even hover detection without clicking. And to wrap it up, we'll make sure that those clicks don't pass through UI controls. Alright, let's get started. Starting with an empty project, I'm using Unity version 2023.2.20. I have not used version 6, so I don't really know what it looks like and how different it operates, but 2020, 2022, and 2023, what I do in this should be pretty much identical for all those versions. If you're new to Unity, that's no problem, just follow along, but if you've never created a project, you're going to want to open the Unity Hub. Give it any name you'd like, make sure you set it to 2D and hit the Create Project button, and you should have a screen that looks very similar to this. In our Assets folder, we're going to create two new ones. We're going to right click and go to Create in Folder. First one's going to be called Sprites. And the other one's going to be called Scripts. The full project and assets are up on GitHub. The link will be in the video description. And we're going to import these two images here and drag them into the Sprites folder. And then I'm going to highlight both of them, Control click. Our sprite mode right now is on multiple, but these are independent images, so we're going to change it to single. You'd want to use multiple if you have like a single image or a single sheet that has multiple sprites in it. But otherwise, in this case, we will be using single. Down here in filter mode, we're going to use point no filter and compression to none because we want to have the best quality for our images. And we're going to click apply. In the hierarchy, we're going to right click and we're going to create an empty game object. We're going to call it game console. If the transform is not at 0, you're going to want to right click and hit reset. Then we're going to add on two components. The first one's going to be a sprite renderer. And then we're going to add on a circle collider. And the first image we're going to drag over into the sprite renderer. And then we're going to go over here to the scene tab. And you're going to see that the circle collider is very small, so we're going to come over here to the radius and we're going to change it to 2.3. The reason I decided to use a circle collider instead of a box collider, or what would even be better would be a polygon collider because it could fit the shape of the sprite, is because later in the video we're going to do animations and you cannot manipulate the points of a polygon in the animation. So I decided to use a circle collider instead because it has the least amount of empty space to click into, where a box collider exposes a lot more. So now over on the game console, we're going to right click and create another empty for it to be a child of the parent. Name it overlay. And then we're going to add on a sprite renderer to it. And then drag in the overlay image. Now, if you don't see the image, this happens sometimes, and what you're going to want to do is just come over here to the layer order and put a 1 there so it sits on top of the other one. And then we can go up here and save our changes. Last we'll do is we're going to come over here to the scripts folder, right click, and we're going to create a new C# script. And we're going to call it click script. And then open that up in Visual Studio. The first script we're going to write is the click script. And the way it works is when we click our left mouse button, we're going to cast a ray into the world. And at ray, if it intersects or hits any colliders, then we'll know what object it is. And then at that point, we can pretty much do whatever we want. But for this tutorial, we're going to change the color of the sprite renderer to red. We're going to remove these two lines because we don't need them. And then we're going to define 3 variables. The first one's to our mouse position. Next one's going to contain the hit information returned from the raycast. And inside that information, there's a collider with a transform on it. And we're going to take that transform and save it in click object. And then we're going to get our mouse position and we're going to send it to a camera function called screenPointArray. And we'll check and see if our left mouse button's been clicked. And then we're going to use the physics function raycast and give it the mouse information. And if there was a hit, then we're going to take the transform and save it in the click object. Otherwise, we're going to set it to null. And if we do get the hit, then we're going to get the sprite renderer on the object and change the color to red. Save the changes and head back over to Unity. In the hierarchy, we're going to add another object. We're going to call it scripts object. And this is where we're going to attach our scripts. So let's hit the play button and try this out. So you can't hear my mouse clicking around, but I am clicking. And I'm going to now click on the object and we got a hit. And we changed the sprite renderer to red. So I'm going to do this one more time, but we're going to do it with a duplication of the game console. So we're going to add a couple more of these guys. So it's able to determine which one we hit and change the color. The next script we're going to write is going to be the click and release script. So I'm going to right click in here and show and explore, and then we're going to go into the scripts folder and we're going to duplicate the click script. And then we're going to open it up, and first thing we'll do is we're going to rename this. We're going to add checking and see if the mouse button is released, and then inside we're going to check and see if the click object is valid, and then we're going to set the sprite renderer color back to white. So back on the scripts object, we're going to attach the click and release script and uncheck the click script, and we can just save this. And let's run the scene. So the way this is going to work is when we hold our left mouse button down and we get the raycast to hit something, it's going to change the color to red. But as soon as we let go of the mouse button, it's going to go back to the original color. So I'm going to click on this, but as soon as I let go, it goes back to the original color. Our third script is going to be the toggle script. So we're going to duplicate the click script. So we're going to rename the class to toggle script, and then we're going to define a new bool that's called isSelected. We'll initialize it to false. Now down in where we test and see if the click object is true or false, we're going to do a comparison to see if the sprite renderer's color is already equal to red. And if it is, then it's going to return true, otherwise it'll be false. And then we're going to check that isSelected variable, and if it is true, we're going to set the color back to white, otherwise we'll set it to red. So back on the scripts object, we're going to add on the toggle script, and then we're going to uncheck the other script. You can save the changes on that, and let's run the scene. So think of this as a light switch. So if I click and release on it, it's going to turn red, and if I click and release on it again, it's going to go back to the original color. So it's an on and off state. Script number 4 is going to be the drag script, and we're going to duplicate the click and release script. Rename the class to drag script, and then we're going to add in a bool called isMouseDown and set it to false. Remove the color changing code for the mouse button down and mouse button up. And then inside of mouse button down, we're going to say isMouseDown is equal to true. And inside of get mouse button up, we're going to say isMouseDown is equal to false. Then we're going to do a test and see if the mouse button is down and that the click object isn't null. Then we're going to shoot out a raycast, and we're going to see if we get a hit. And we're going to compare the first hit that we got against the second raycast hit and see if the instance IDs are the same. And the instance ID is going to always be unique between every object in your scene. And if they are equal, then we're going to change the color of the sprite renderer to red and exit out of that section. Otherwise, if there isn't a hit, then we're going to change the color of the sprite renderer of the click object back to its original color. So add the drag script over to the script object. If we click and hold our mouse button down, it's going to be red, and we're still holding the mouse down. Now after we take it off, and there's no more collision, it'll go back to its original color. But if we bring it back over while still holding the mouse down, we got a raycast hit and it'll be red. So we can go on and off while our mouse is down. Our fifth script is going to be the hover script, which is basically just like the drag script, except we're not going to be holding any mouse buttons down. And we're going to duplicate the click script and rename it to hover script. Rename the class to hover script. And then we're going to change the click object transform to one called previous hover object and next hover object. And then in the update loop, we're going to take the next hover object transform and assign it to the previous hover object, so we can keep track of the one that we had before. And then we're going to use a raycast and then get the transform of anything we hit and save it in next hover object. And if we did hit something, we're going to change the color of it to red. And then what we're going to do is we're going to check and see if the next hover object and the previous hover object are not null. And then we're going to check the instance IDs of both of those and see if they're not equal to each other. And if they're not, then it means that we switched objects and we're going to change the color of the previous one back to its original color. And if we didn't have a next hover object to begin with, then we're going to check and see if we had a previous hover object, and then we're going to change its color back to its original. Add the hover script to the scripts object. So now I'm not going to hold the mouse button down, but if I hover over it, it turns red. And if I move my mouse off of it, it goes back to the original color. So let's duplicate this. Our last script is going to stop our mouse clicks from passing through UI controls. But before we create it, we're going to add in a canvas. So in the hierarchy, we're going to right click and we're going to go to UI. And if you don't have a UI menu option here, then you're going to go up to Window, and then you're going to go to Package Manager. And then over here in the Unity registry, we're going to search for Unity UI. And then you're going to install this. So then we're going to add the UI. I'm going to go to Legacy and then Button. And then let's just scroll out here. And then we're going to move our button to the center. So hold down the Alt key and then left click on it to put it in the center. I'm also going to change the size of it. I'm going to make it 200 by, let's just say 60. And then we're going to change the text. Let's just say click me. And we'll change the size of it to 28. So then we can go back over to our scripts, or not our scripts, but our game console, press F on the keyboard to jump over to it. Then we can save. And let's test this out. So we're just going to run it. So if I click the object, it changes color as expected. But if I click on the button, you can see that the raycast passes through the button and hits the object behind it. And that's something that we don't want. So we're going to create one more script to stop that. We're going to duplicate the toggle script, and we're going to call it block UI script. Change the class name to block UI script. And then we're going to bring in the Unity event system. In the update loop, we're going to check the event system and see if our mouse pointer is over a UI control. And if it is, then we're just going to exit out of the update loop. So none of our mouse code is going to run. Add the UI script to the script object. So now we're going to try clicking on the button, and now we can see that the raycast is not passing through and hitting the object behind it, but we can still hit the object outside of the button. You made it halfway through the video. Nice job. So far you've learned how to code different types of mouse clicks, use raycasts, detect when you hit a collider, and identify which object it belongs to. Plus you've seen how to change the color of a sprite renderer. Now in the second half, we're going to jazz things up a bit. We'll add a background to make the scene look better, and build an animation for our game console. Instead of just changing a sprite's color when we detect a hit, we'll trigger an animation instead. First thing I want to do is add in a background. Head into the sprites folder and import the image. We'll apply the same properties as we did before. Single for the sprite mode, point no filter, and no compression. Hit apply to save the changes. In the hierarchy, create another game object. Name it background. Add a sprite renderer to it, and give it the background image. That looks a lot better. Let's disable the game console and canvas by clicking the checkbox next to their names in the inspector. We're going to create a new game console for our animation, and towards the end of the video, we'll bring back the canvas for the block UI script. Next, we need all the images for the animation. Let's import those. Open the black folder. Highlight all the images and update the 3 properties like before. Time for the new game console. Create a new game object and call it Game Console Black. Add on an animator component. This will control the animation. A sprite renderer, and a circle collider 2D. Make the collider radius 2.3. Up top in the transform, set the Z to -1. This is to make sure the game console is above the background. The default image for the game console will be the lid closed. Drag that image to the sprite renderer. Let's save the changes. Okay, here comes the fun part. It's time to build the animation. Create a new folder in Assets and call it Animations. Then inside it, create another folder, call it Black. Right-click, go to Create, and choose Animator Controller. Name it Game Console. Right-click again and create an animation. Name it Game Console_Open. Select the Game Console object and drag the Animator controller to the Animator component. Double-click on the Animator controller. It should open in the Animator window. The Animator controls animations assigned to it. There will be an entry or default, and it starts playing when the game object runs. This is fine if, say, you have an idle animation, but for our game console, we don't want anything to play right away. To solve this, we're going to create an empty state and use that as the entry. Our animation will still be part of the animator, but we'll tell the animator when to play it through code. Right-click in the Animator panel and select Create State and Empty. To make this easier, I'm going to move the Animator window over to the side. Drag in the animation clip. Okay, so now we're going to move the window back. Select the Game Console object, and this time drag the animation window over. On the Project tab, go to where the sprites are. Use your mouse wheel to zoom in on the timeline so that you have 30 frames in view. Drag all the sprites into the timeline. You should now see a blue vertical bar to the right of the last one, but if you don't, drag your mouse to highlight all the sprites. Grab on the bar and drag it to the right, and the sprites will start spreading apart. Bring it out to the 25 mark. Each sprite should play for 5 frames, except for the last one. And to fix that, we could either add a copy of the last sprite at the 30 mark, or add in a keyframe. And we're going to use the keyframe option. Click on the 30 on the timeline to move the marker, and then click the Add Keyframe diamond. The idea is that the game console will open on a raycast hit, and it'll close on a raycast miss. To handle the close, we could make a separate animation with the sprites in reverse, but that isn't all that efficient. There may be cases where you would want to do something like that, but for this simple animation, we won't. Instead, we'll add a parameter to our animator that will control the speed, or in this case, the direction. It'll be a float that will have a value of 1 or -1. That value will be used to multiply against the speed. If it's positive, the animation will play forward, showing the game console open, but if it's negative, it'll play in reverse and show the game console close. Back on the animator window, you have 2 tabs on the left side, Layers and Parameters. Click on Parameters if it isn't already open. Click on the plus sign to the right and choose Float. We're going to name it Direction and set its value to 1. Then click on the Game Console Open animation. On the right there will be some properties. Put a check on the parameter for the multiplier line that's under Speed. The direction that we created should already be filled in. Go up and save your project. Next on the agenda is to make changes to our scripts So go over to the scripts folder and open up the Click script in Visual Studio. This time around we're going to edit all the scripts first and demo the changes after. Starting with the Click script, we'll comment out the color changing code and add 2 new lines. From the Click object we'll get the animator component and make a call to the setFloat function. The first parameter is the name of the float we want to use, which is direction that we defined earlier. The second parameter is the value, and here we pass a 1, meaning we want the animation to play forward. The next function call is to play the animation. We give it the animation name, GameConsoleOpen, and then the layer index, which is -1. Finally, the normalized time, which we set to 0. Think of the normalized time as the progress through your animation in terms of a percentage. So like 0 is the beginning and 1 is the end. For instance, if you wanted to start halfway through, you'd use 0.5. This code will play the animation forward from its beginning. Next is the click and release script. When we press our mouse button down and we get a click object, we play the animation forward. Once we let go of the mouse button and there is a click object, we play the animation backward by setting the direction to -1 and the normalized time to 1, meaning to start from the end of the animation. In the toggle script, we get a handle to the animator component and the access the clip info and state info. We check to see if the clip info has a length, meaning there is an animation. For the isSelected bool, we see if the normalized time is greater than or equal to 1, meaning the animation played forward. Otherwise it may have not played or it did it in reverse. Using isSelected, we set the direction of normalized time. Realizing this after the fact, I should have wrote those as animator.setFloat and animator.play instead of using the long code. For the drag script, we define a bool isPlaying to track whether the animation was started. We need this so it only runs once until its state changes, because in the update loop, the play function can get called multiple times, and it'll appear your animation does nothing because the normalized time is reset. When the mouse is down, we check and see if isPlaying is false, and play the animation forward, and set the bool to true. If there isn't a raycast hit, then we see if isPlaying is true, and play the animation backward, and set the bool back to false. The hover script follows the same pattern as the drag script. We declare a bool to track whether the animation was started, and don't trigger it again until there is a state change. If there is a next hover object, we play the animation forward. If we switch objects, then we play the animation forward on the new one and reverse on the one we left. If there is only a previous hover object, then we play the animation backward. Alright, let's try out the click script. If we click on the game object, it'll play the animation. And if we keep clicking on it, it'll just keep starting at the beginning and playing it forward. With the click and release script, if we click it and let go of it too soon, it'll close up right away. So we have to actually click and hold our mouse down and it'll stay open, and as soon as we let go, it'll close back up and gives it a little bit smoother of an animation. For the toggle script, if we click on the object, it'll open up, and if we click it again, then it'll close. And if we duplicate these items, you can kind of see there's a little bit of a laboring problem when we click on them. So to fix that, you're going to want to change the Z on the transform to a negative number. The higher the negative number, the closer they are to you, and they'll sit on top of the other ones. And with the drag script, if we click and hold our mouse button and hover over the item, it'll stay open, and as soon as we move our mouse off of it, it'll close. And you can see with duplicated objects, if we click and hold our mouse button on one and then move our mouse over to the other one, it doesn't open. It only works with the one that we currently clicked on. And our last script that we're going to try out is our hover script. If we move our mouse on top of it, you can see that it opens, and as soon as we move our mouse off of it, it'll close. And with duplicated items, it's the same. Whichever one happens to have the mouse hovering over it will open, and if it moves off of one, it'll close up. So you can see I have all the game consoles on the screen now with the hover script activated, so I can roll through each of them, and as they get passed over, they open and close. So I'm going to turn on the block UI script and reactivate the canvas. I've added a button for each console, and if I click on each of these buttons, you can see the ray doesn't pass through them still, but I can click on the game console itself and it still opens. And that's a wrap for today's video. If you enjoyed the video, don't forget to hit that like button and subscribe for more game dev content. You can find the project source code over on GitHub, and if you want to chat with other game devs, be sure to join our Discord community. All the links are in the description below. This is GameDev with Tony signing off. I'll see you in the next video. Take care.